Okay, so you're supposed to try this. We're going to take a look and see how you did. This is number 25, and I'll tell you when to pause it so you can go work on 26 and then come back to the video. So 25, you need to start with your P and Q. P is this value right here. This is your constant, and there's lots of factors for this P value. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 8 times 3, 2 times 12, and plus or minus 24. That's a ton of options. The good news is hopefully we'll find one of them here quick. And then the good news is for our Q value, it's just plus or minus 1. And what that means is when we do our ratio of P over Q, it just ends up being what the P's are anyway. So P over Q, this is official for rational root theorem, is just 1, 2, 3, 4, 6, 8, 12, and 24. Now, if you get really lucky and you hit on one of these the first time when you're plugging in for factor theorem, that's all you have to do. It just stinks if you don't get a factor until like way over here. But usually it happens within the first 4 substitutions. We're going to start with substituting positive 1 in. We're going to check that one, test it, and see if it is a factor. And if it is, it will end up in 0 at the end. So I've got 1 to the third plus 3 times 1 squared minus 10 times 1 minus 24. I don't think that's going to work. I don't think so. This is 1 plus 3 is 4 minus 10 is negative 6, and that's a negative 30. So that's definitely a no. Let's see what happens if we try negative 1. So negative 1 here. I don't know if we'll make it yet. We'll see. This is going to give me negative 1, and this is going to give me positive 3. So that's going to give me positive 2. 2 and 10 give me 12, and 12 minus 24 is negative 12. So this is still a no. Okay, so the ones don't work. Let's try 2. I'm telling you, this is all just trying to find one of them that works so that we can get a depressed polynomial. These are getting bigger numbers, so I gotta actually write them down. I just put them in the calculator to hold them. This is 8. This is 4 times 3 is 12. This is minus 20. And this is minus 24. Nope, that's a negative 24. Good grief, I hope we get one with this negative 2. I didn't even look at this answer, so I don't know what my first factor is going to be. I'm doing it like you would. I'm just going down the list, finding the one that works. So I'm trying negative 2 now, see what happens. This is negative 8. This is positive 4 times 3 is 12. This is positive 20. And this is minus 24. Ah, we finally got it, a 0. Woohoo, this is a solution. It gets really depressing when you check down 6 or 8 of them and you still haven't hit yet, but I'm glad we found one. Now that we know that negative 2 is a solution because the factor theorem tells us that if we have a 0 remainder, then it's a factor, we're actually going to start on the synthetic division. So we're going to use negative 2 and use synthetic division. Negative 2 on the outside. These are in order. I'm just going to put the coefficients down. So we've got 1 from the x cubed, 3 from the x squared, negative 10 from the x, and negative 24 is the constant. Remember to always bring your first guy down. So the first term we have is 1. We're going to bring it down. And then you multiply and add. Multiply and add. Multiply and add. I don't know if you remember me saying this, but we are anticipating that it's going to end in 0 because if it's a solution, then it has 0 remainder, and this is the remainder spot. So this should match your 0. We're not doing it to get the remainder. We're doing it to get the depressed polynomial. This is my depressed polynomial right here. And when we do synthetic division, our degree is 1 less than what we started with. So if this is a cubic, this is going to be x squared plus x minus 12. And what we're going to do is take this depressed polynomial and we're going to factor it. Okay, so I don't know if you necessarily need the magic x, but we'll hit it. A times c, that's 1 times negative 12 is negative 12. Our b term is positive 1. Factors of negative 12 that add to 1. We would need 4 and 3, where the 3 has to be negative for these two to add to a positive 1. When we make our factors, we need x plus 4 and x minus 3. We don't have to divide by anything because my coefficient is 1. Then we have to solve. So we set it equal to 0 and solve. X plus 4 is 0, so x is negative 4. And x minus 3 is 0, so x is 3. Let's highlight our answers. All right, those are our solutions. We have a cubic, we have all 3 rational roots, and now we can set up to sketch it. Moving my paper up a little bit so we can get there. All right, our degree is 3. It's a cubic. Our a term is positive, which means that we have n behavior that looks like this, starting down and ending up. Our y-intercept is 0c, in this case 0, comma, and our constant is negative 24. And our x-intercepts that we solved for, that I highlighted, were negative 2, negative 4, and 3. Negative 2, 0, negative 4, 0, and 3, 0. Let's go ahead and plot this. Not plot it, but sketch. There's like random smudges on my page that I want rid of. Okay, so negative 24 on the y-axis, we'll put way down here. We need a negative 4, 2, 3. Let's do negative 4 here. Negative 2 here. Positive 3 here. It's got to start down and end up. So I got to, I'll do it in blue. Down. Cross, 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 cross. You're just going in order, following that pattern, and you're all done. All right, this is where you're going to pause the video because you're going to go back and you're going to do number 26, and then come back to the video at 8 minutes and 30 seconds to see number 26 being done. You back? I'm back. All right, here we go. P is 27. All of the factors of 27. 1, 3, 9, 27. As far as the Q goes, plus or minus 1. So that's it. This over 1 is just itself. So when we are looking for all the possible roots, solutions, x-intercepts, however you want to call it, we've got plus or minus 1, plus or minus 3, plus or minus 9, or plus or minus 27. So because there's such a small list, I'm hopeful that when we go to plug in, we'll find one right away. Let's hope there's one there. We haven't been lucky that yet. I don't think we are here either. This is 1. This is 1 times 3, so this is 4. Minus 9 is negative 5. And 27 would be negative 33. Nope. It'd be nice if one of them was x equals 1, wouldn't it? We could just stop right there. Maybe negative 1 will work. This is negative 1. And this is a 3. So it's going to give us 2. 2 and 9 is 11. And 11 minus 27 is a negative 16. Still no. All right. Here's our third try. Got to put a 3 in. Three to the third power is 27. And 3 to the third power, right? 3 squared and times 3 is 3 to the third power, still 27. So that's positive 27, positive 27. This is negative 27, negative 27. Ah, there's my 0. So we got a solution. I still would have liked it on the first try. So what we're going to do now is we're going to take our 3 and we're going to do synthetic division with our solution of 3. We are anticipating 0 to come out at the end, but we're more interested in our depressed polynomial so that we can factor it. So bring down. 1 times 3 is 3. 6 times 3 is 18. 9 times 3 is 27. There it is. Got the 0. So these have to match. But I'm looking for my depressed polynomial, which is this guy right here. That's what I have to factor. Remember, if we're starting with a cube, this goes down by 1 degree. So this is going to be a 1x squared plus 6x plus 9. And we're going to factor that. Magic x, 8 times c, 1 times 9 is 9. B, that's really a 9. B, we need a 6. We want factors in 9 that add to 6. Oh, it's positive 3 and positive 3 all day. Oh, how cool is that? That means I have x equals negative 3 and x equals negative 3. This is a double root, guys. When we go to graph this, that's something that's going to happen. Okay, double root. Those are our solutions. I can't wait to graph this one. It's so cool to see it all unfold. So there's our 3. 1, 2, 3 with a degree of 3. So there you go. Sketchy, sketchy. Degree is 3. It's a cubic. We don't know by now. Our A is positive and our M behavior for a cubic when A is positive looks like this. Our y-intercept for this one is 0, comma the constant, and the constant is negative 27. And our x-intercepts, now watch this. I've got x equals 3, so that's 3, 0. And then I've got x equals negative 3. And this is a bounce. Don't forget, because it happens twice, it is a bounce. Let's sketch. Negative 27 down here. I need a positive 3 and a negative 3. I know it's got to start down and end up, but I know it has to bounce here. So this is how you do it. It's got to start down here. It's got to bounce at negative 3. Do you know what that means? That means it's going to bounce from underneath. It's going to hit that y-axis and then boom, go through a positive 3, just like that. And there's your sketch. Thank you so much for listening. You need to ask questions and you need to get started on your homework. Good luck, guys. Contact us with questions.